Welcome to Efiwe, excellence without stress.
Good day, guys. Hope I met you very well today, and I hope we are all doing fine. Today we are back to Saddle, and this is Efiwe, excellent without stress. This is where we teach you some mathematics topic. Hi, I'm your mathematics teacher, Adigbite Otsi. Here today, I will be taking you on another topic, which is binary operation. So, although we don't cover everything, but the little we cover, we believe that it should be enough to pass your Jamb for this year. So today, we'll be talking about binary operation. Now, when we say binary operation, what comes to your mind is we've done binary number, although this one is quite different because we have some specific operation that has come to play in mathematics, and all these operations are well defined in their own unique way. So let's see this. The operation can actually be combined with two variables, and that is what we have in our screen here. We have binary operation which can be evaluated through direct substitution. So what do we call an operation? A binary operation is what has been posted on your view here, which we use this symbol. So we can use different symbol for a binary. We can use operation star. We can use many operation which symbolize a unique element, which symbolize how to join unique elements together, and all operation that will be giving you today will be well defined. So when we have the first example, we say that a binary operation hat on a real numbers is defined by x at y, and then when we say definition of this binary operation, this is what we have as the definition. So here we have xy plus x plus y for two real numbers x and y. So which means that x and y are actually real number. So which means that the numbers are in existence. So how do we operate as far as binary number system, binary operation is concerned? So obviously we have to find the value of 3 and minus 2 and 3. So you can see the positioning of the two real numbers. So which means that one will be going for x and another one will be going for y. So what we need to do is to just make a direct substitution in order to get our value. So here from example 1, I have x at y, which is equal to xy plus x plus y. So which means that my x will be equal to 3 and my y will be equal to minus 2 over 3. So from here, anywhere I see x, I put 3 from what is being defined, and anywhere I see y, I put minus 2 over 3. So here I have a simple manipulation here, and I have 3 can cancel 3 because this one is in form of fraction multiplied by a whole number. So which means that it can be reduced. So here I have minus 2 plus 3, and I still have minus 2 over 3 because my addition sign will multiply my negative sign here. So here I have something like this if I take the LCM. So once I am able to do my addition and subtraction properly, I'm going to get 1 at the numerator and 3 becomes my denominator. So you can see how simple it is. So that is what we'll be doing as far as this topic is concerned. So although we still have many of hits that we are going to be bringing to our view. So let's check the second part of this. So here we have if m star n, obviously this is star here, which is symbolizing a binary operation. So here we have m star n to be equal to n minus open bracket m plus 2 for any real numbers m and n. We have to find the values of 3 star minus 5. So obviously our operation has been well defined here as n minus open bracket minus m minus open bracket m plus 2. So which means that anywhere I see m, I put 3, and anywhere I see n, I put minus 5. So this one has come to play in such a way that we have a direct substitution. So that is why we have minus 5 minus open bracket 3 plus 2. So which means that inside our bracket I have 5, and once I'm able to perform this operation at the end of the day, I'm going to get minus 10, which makes the operation to be very simple. So here we have the next example. A binary operation had on real numbers is defined as by x star at y equals xy plus x plus y. For any two real numbers x and y, we have to find the value of these real numbers, which is minus 3 over 4 at 6. So obviously, anywhere I see x, I put minus 3 over 4, and anywhere I see y, I put 6. So this has come to play in our solution. So in our solution here, I have x at y, which is equal to this, and I substitute my value in order to get 3 over 4 at the end of the day. So let's check and for another example, and let's see how we can solve those examples as well. So let's check this. Now you can see that we have different operation that has come to play in a row here of a binary operation. So we have a question like this: a binary operation star on the set of real numbers is defined as x star y, which is equal to x squared minus y squared whole over 2xy. We asked to find the value of minus 5 star 3. So which means that here we still make use of direct substitution. So which means that anywhere I see x, I put minus 5, and anywhere I see y, I put my 3. So here I have minus 5 all square, and I have 3 square here. Everything divided by 2 times minus 5 times 3, and that is what we have on our screen. So I will urge us to actually take our time very well. We can pause the video and try some things on our own, because watching the video might not really help us, but we putting our pen on paper and try to solve some problems on what we have actually showcased to you will really help us to actually assimilate very fast. So from here we have minus 5 times we have minus 5 times 3 times 2, which will give us minus 30, and at the end of the day we have 16 divided by minus 30 at the numerator, which means that at the end of the day, when we reduce the expression, we are going to have minus 8 over 15. So which means that minus at the denominator is sharing for both numerator and denominator. That is why we have actually decided to place our negative sign at the numerator. So here we have another question. So here we have another question. If m star n equals m over n minus n over m for m n in R, so which means that R is representing a real number. So which means that any value taken from m and n will be taken from real value number. So which means that we have to evaluate minus 3 star 4. So if you have to evaluate minus 3 star 4, obviously our m here will be minus 3. Our n here will be 4. So when we substitute it directly to the expression that is being defined, then we have minus 3 over 4 minus 4 divided by minus 3. So when we take the LCM here, the LCM obviously is minus 12. So when we perform the operation, we are going to be having minus 9 minus 16 all divided by minus 12. At the end of the day, we have minus 7 divided by minus 12. Then minus we cancel out, and we have our final answer to be 7 over 12. So let's take a look for another question, and here we have this. You can pause the video and try to check this whether you are going to get it right. So from here, this looks different. If a binary operation star is defined as x star y, which is equals to 2x plus 2y. We are asked to find 2 star 3 star 4. So which means that 3 star 4 is inside the bracket. So here now we are going to deal with the one inside the bracket first and get the value before we associate it with the other one outside, which means that we are going to have 2 star the answer that we get inside the bracket. So we deal with the one inside the bracket first. So that's why you see us writing 3 star 4 here. So here now we have 3 star 4 to be substituted inside this expression. And anywhere I see 3, I put x. Anywhere I see 4, I put y. So that is why we have 3 plus 2 into bracket 4. So 2 into bracket 4 gives me 8, and we have 3 plus 8, which gives me 11 as 3 star 4. So which means I'm going to substitute my 11 inside this bracket. Then I have another operation, which is 2 star 11, in which I have to find in the same binary operation being defined. So here we have 2 as x, and our y will change to 11. So when we substitute it inside the same expression, we will be able to get 24. So that is what we have for this case. So we go to the next case, which is this. So I want us to actually try this on our own part also, so we can do ourselves good by pausing the video. So when we pause the video, we try to check how far we can go as far as this question is concerned. So for this question, we have a binary operation star is defined by x star y, which is equal to xy minus y minus x for all real values of x and y. Now, if x star 3 equals 2 star x, we're asked to find the value of x. So obviously, we can do from the right hand side. We can go for the right hand side first, and later go for the left hand side, or we substitute the two at the same time inside this binary operation. So which means that at this side, my x still remain x, my y still remain y. Sorry, my y remain 3. So for this side, so that is why we have made a substitution here. So whenever I see x, I put x, which is this. Whenever I see y, I put 3 for this side. So that is why you are seeing me writing this. So the same thing happens to the other side. Whenever I see x here, I put 2. Whenever I see y, I put x. So I substituted it for each other, and I have something like this. So when I collect the like terms, been able to get the value of x to be equal to 1. So here is my last example for the day for this part. So a binary operation star is defined by a star b, which is equal to a cap b. Now here we have, if a star 2 equals to 2 minus a, we are asked to find the possible values of a. So from this question, we have a binary operation star is defined as a star b, which is equal to a cap b. If a star 2 equals a square, so we are asked to find the possible value of a. So how do we get this? So we are asked to find the possible value of a. So how do we get this? We're told that a star b equals to a cap b. So obviously, we have to be very careful here. So Anywhere I see A, I put my A, but anywhere I see B, I put 2. So that's one has come to in place here. Sorry. I have to edit it. Okay, we have this question. A binary operation star is defined by A star B, which is that's in. Sorry, I have to take this part again. So this is the final take. Okay, checking this question, we have a binary operation star is defined by A star B equals A raised to power B if A star 2 equals 2 minus A. We are asked to find the possible values of A. So which means that here we have A star B to be equals to A raised to power of B. So which means that anywhere I see A, I put my A, and anywhere I see B on the binary operation star, I put 2 there. So I will substitute that one first, and I got A squared. So which means that anywhere I see A, I put A, and anywhere I see B, I put 2. So which means I got A squared. So if this binary operation answer is equal to 2 minus A, and that is what you see at the next paragraph. So which means that here this is forming quadratic equation. So which means I have to find the factors of this quadratic expression, which is minus 1 and plus 2. So at the end of the day, when I factorize, I've been able to get A equals to 1 or A equals to minus 2. I hope this is clear, and I'm going to have some questions to ask us if we are able to assimilate this, and this one will show, and as I provide the answer to the question I'm going to give us at the end. So wait for the end, and here is the question. Yeah, here is a question I have for you today on this topic, and I urge us to actually put our pen on paper to exercise some strengths and solve these questions. So if we are able to solve it, it shows that we are a mathematics guru on our own. So I hope this is clear. And here are my answers. So if you are able to solve and get this answer, then I hope that you are good to go, and I believe you should be able to watch out for our next video. So thank you. God bless you.